Hello, this video is going to be devoted to studying the k-means cluster analysis feature in RapidMiner, which is a software package used for text mining. This video is being made for my social research methods courses that I teach, but if you're not part of that, hopefully you can still find something useful here. So I've already logged into Vidya, our site that we use to access the software, and I have launched RapidMiner. Then we're going to begin by importing a process. So File, Import Process, and then we're going to go to the top level in this menu, then Data, Oniata, Clustering, and we'll be using the vfracking clustering file there. Okay, so that's going to open up, and you can just close that file that opens with it. Okay, we're going to then right-click on Local Repository and choose Store Process here, and then click OK. Now I've already got it there, so I'm overwriting it, and that's fine. And then if you expand that out, you should see where the file is, and there it is. And I have some other stuff here. Don't worry if you don't have the same stuff. We all have different repositories. Okay, so next we're going to import some data. So that's here with this icon. If you choose this arrow, import CSV file, and we'll go to the top level, Data, Oniata, and this time we're going to go down to the word list folder, which is where we've stored our data, and choose the fracking results file. We're looking at Twitter data that's related to the discussion of fracking. So we're going to import the file again. We're going to uncheck the skip comments, and we're going to select comma because it is a comma separated value file, and then we'll click next, and again. And this time I'm only going to import the description category. So I'm going to deselect all the other categories we have in our data set. And then we're going to specify that this is text. Okay, so click that and choose text. Click next. We have to name this, so let's call this description analysis fracking, and then finish. And then we're brought to the results view, which shows us the data we've imported, which is just one column, which is our text. And if we go to the pad of paper and pencil icon, we'll go back to the process view. So now we need to click this retrieve CSV file box here, this operator, and specify the data that we just imported. So let's find it in our list here. Okay, frac data, description, cluster analysis. I've done this a few times. There it is, description analysis fracking. Okay, so now we've specified where to find our data. We're actually going to delete this box. We're not going to use that in this particular iteration of the exercise. And then we're going to connect the out to the example, the EXA input port. Okay, and then we'll drag this over. And then one more thing, we have to come over to where it says write CSV and click that. We'll then choose where we're going to store our data file we'll be writing. And we can keep this if we want, or we can name it something else, but we do have to drop this out and choose CSV file. So let's just call this the output cluster analysis fracking. Okay. And we'll choose where to put that, and I'll just leave it in the default location, which is my repository. Alright, so now it knows where to write a new CSV file we're going to be creating in this analysis. So after we've made those changes, we're able to click Run, and it will go through the process. And you'll notice the green arrow moves through the different elements of our process. And when it's done processing, it'll bring up our results. So the first thing that I see in this results is the correlation matrix that's created. And so out of the data, the text data, it pulled out some of the keywords here. And of course, this is a short list of words because we used a lot of filtering, and we've taken out a lot of non-words and less frequent words, and just kind of looked at the core of the most frequent terms. Alright, you can play around with looking at some of the other views here, the pairwise table, the plot view, annotations. Plotting allows you to make some different graphs, so we'll not mess with that right now. I do want to look at the cluster model over here. This is a different tab, because this is our primary interest in this analysis. And if we click the centroid table, we'll see those same terms that were in our correlation matrix. And this time we're going to look at how those terms correlate with particular clusters. Right? These are inductively derived clusters or dimensions of our text. And so we see, for instance, in cluster 0 that the terms chevron, gas, shale, water come up. All right. And in cluster 1 we see gas again comes up, but this time oil, although oil does not come up in the first cluster. So this cluster 1 has a dimension that has to do with gas and oil primarily, while in this one it has more to do with chevron and water. So if we go back to our process file, which is this pad and paper with a pencil, we can modify the number of clusters we create. So if we click on this box here, the clustering one, we see that k is equal to 3. We're specifying 3 clusters be created. Let's change that value to 6. So that we'll see what happens when we do that. We'll rerun the process. Okay, we get the same kind of results, and this time let's click on the cluster model again and go back to the centroid table. So now we've asked RapidMiner to create 6 different dimensions, right, to see if this makes any sense. And this time cluster 5 has protesters, site, and Romania, right, Romania, however you like to say that. So apparently this has to do with all Twitter tweets that have to do with protesters primarily, right? So protest dimension. This one has to do with oil primarily. You see 0.88, and that's the biggest one, in gas. So that's similar to our cluster 2 from the previous analysis. This one, cluster 3, has to do with shale and gas and chevron. But shale is the predominant term here. In cluster 2, chevron is the predominant term, and that's correlated with Romania, and site. In cluster 1 is primarily having to do with gas. In cluster 0 doesn't have much going on, but it has a little bit to do with water. All right, so you can see from this analysis that if we alter the number of clusters, what we're doing is we're telling RapidMiner to find different numbers of themes or dimensions within the text data that we're providing. And if we want, we can also view the centroid plot view, which will show you how the different clusters appear in a visual way next to the terms, right? So in this case, cluster 1, you see, loads up around gas primarily. Cluster 4, this yellow one, has to do with oil. This red one is cluster 5. It has to do with protesters. Romania, cluster 3, and so on, right? So this is a visual representation of the dimensions that we've created, showing us the primary loadings for the different terms that are in our text. All right. Again, this is graph view just shows us the number of clusters we're pulling out. The folder view can show you the actual number of which documents or rows in our data file are classified within these different clusters. All right, so that's helpful. Go back to the correlation matrix. You can see how these different terms, this will be the same regardless of the number of clusters. This is a correlation matrix between the terms, so we can see how they correlate with each other. So gas and chevron correlate, Romania and chevron, chevron with shale and site, and so on and so forth. So that is a brief walkthrough looking at the correlation matrix creation and the cluster analysis of textual data. You can see where this can be a very helpful way to examine unstructured text in a data file. And I would like to thank you for watching.